Okay, guys, here we go. Let's start this chapter on blood vessels. I think this is probably the most challenging chapter as far as memorization goes. A lot of things to memorize, but not really that difficult once you get go over it a few times. So, anatomy of the blood vessels for chapter 14. Okay, blood vessels then are going to be the tubes that are going to carry blood away from the heart to all the tissues in our body, return it back to the heart. So, as they leave the heart, we've been over this once before. Number two, arteries carry blood away from the heart. So as we leave the heart, the first branch we have are going to be arteries. Those arteries in number three are going to branch into smaller vessels, and those are known as arterioles. Right? Those arterioles then branch into number four, capillaries, and the capillaries are where we have the exchange of the blood gases right there. Okay? So we got arteries to arterioles to capillaries, and then we're going to return the blood back toward the heart. The vessels are going to do that from the capillaries. Capillaries will merge, number five, to form venules, venules, and those venules then merge to form larger vessels called veins, and those veins are going to merge into the two largest veins that bring the blood back to the heart, which would be the superior and the inferior vena cava, if you remember from your drawing. Okay. Then number 8 says angiogenesis. Genesis means beginning, so angiogenesis refers to the growth of new blood vessels. So let's talk about the basic structure of a blood vessel. And on our picture here, as I get rid of my face here, all right. In our picture here, you're going to see an artery up here on the left, all right, and a vein up here on the right. And there are some similarities, but there are some distinct differences as well in these, all right? So blood's going to flow through the open part of this blood vessel or the tube, and the open part of any tube we talked about when we did tissues and looked in our microscope back in week 1 is known as the lumen. So the lumen's the open part where the blood is going to flow through. And then we have 3 layers to the wall of the blood vessels here, all right? First one, starting on the inside and working our way out, we have the tunica interna, the internal layer, all right? Consists of the endothelium, and this is an important term here. Endothelium is the inner lining of the blood vessel, all right? It's going to be consistent with the endothelium, inner lining of the heart. But the endothelium, make a note of this, because the physiology teachers really stress this. Endothelium, since it's lining tissue, so when we did tissues, we said covering and lining tissues are known as epithelial tissues. So the endothelium, make a note, is epithelial tissue. Okay? Then from there, the next layer is the basement membrane. And then we have a layer of what looks almost like Swiss cheese right there, doesn't it? It's called the internal elastic lamina. So those are the 3 layers of the tunica interna. Then we have the middle layer, which happens to just be the thickest layer right here, and it's called the tunica media, the middle layer, right? It's made up of some elastic fibers, all right? And that allows it to distend or stretch, all right? And then we have smooth muscle fibers right here. So this is all smooth muscle, okay? Internal organs, smooth muscle. All right, and then there's fibers there that are regulated by the sympathetic nervous system, and what those do, those regulate vasoconstriction and vasodilation, which we'll cover in just a couple of minutes here, okay? And you have a little less prominent here, external elastic lamina, another layer of Swiss cheese, which again is part of the tunica media. So primarily for our intents and purposes, okay, tunica media just has the smooth muscle layer and the external elastic lamina, and then the outer layer is known as the tunica externa, which is primarily collagen fibers and elastic fibers, all right? Letter B in your outline on number 3 states that larger blood vessels, okay, since there's a lot of smooth muscle tissue needs a blood supply to stay alive and healthy, right? So larger blood vessels are served by their own smaller vessels called vasa vasorum, and those are located within the wall of the vessels themselves. Okay, so going to letter C in our outline, we have arteries. So let's focus right here primarily on the arteries. We have 2 really important terms here. First one, number 1, vasoconstriction, V-A-S-O, constriction, all one word, right, occurs when vascular smooth muscle tissue contracts to decrease the diameter of the lumen. So essentially what's happening is this smooth muscle tissue is contracting, squeezing the lumen a little bit closer to its walls inside, which means it's decreasing the diameter, so vasoconstriction. All right, number 2 is vasodilation. When this smooth muscle layer relaxes, it moves outward. That increases the diameter of the lumen. All right, so vasoconstriction decreases the diameter of the lumen. Vasodilation, when it relaxes, increases the diameter. All right, we have two major sets of arteries here. First one, you have large elastic, what's called conducting arteries, and they have mainly elastic fibers in here that have a lamellae. What these do, these will recoil when the heart relaxes, and that forces the blood to move further along, and those blood vessels then act as what are known as pressure reservoirs. So highlight that. The pressure reservoirs are the large elastic or conducting arteries. The other ones are more medium-sized muscular arteries, which are also referred to as distributing arteries, and these are able to undergo greater vasoconstriction and vasodilation, and that allows the blood to go specifically to certain targeted tissues that we want to take more blood to. And then the wall itself is maintained by what's known as vascular tone. That keeps the wall of the vessel stiff. So we go away from arteries and we go to arterioles. All right, we're going to go to our next image down here when we look at the arterioles. Okay, so in my images, if I can click on those and find them, all right, and get to the right one, let me pause. Okay, so these are going to be arterioles up here, and let me see if I can shrink that, bring that up just a little tiny bit there. All right, and okay, so I may have to squeeze this kind of back and forth. All right, so we have our arterioles up here. So this is where our arteriole is. So the arterioles, okay, is a small branch of an artery. It's going to be the middleman between the arteries and the capillaries, essentially. It delivers blood to the capillaries, and you'll see here are capillaries right here. Okay. Through vasoconstriction and vasodilation, arterioles have two main roles here. Number one, they regulate blood flow from arteries to capillaries, okay, act as the middleman, like I said before, and they also regulate blood pressure. So arterioles, number three, are known also as the resistance vessels. When we measure blood pressure, we're measuring resistance, okay, and blood flow. So these are known as the resistance vessels. So highlight that with the arterioles, okay? The terminal end of an arteriole, you come down here, is called the meta-arteriole. You'll see that term right there as I scroll around that. So the meta-arteriole is essentially going to make a junction here with the capillaries, and these junctures are known as precapillary sphincters. So those are the precapillary sphincters right there. Then we get to the capillary level itself. So a capillary is a microscopic blood vessel, very small. Okay, it connects the arteriole to the venule, as you can see down here. It's in the middle between those two. All right. The flow of blood from the arterioles to the venules through a capillary is known as the microcirculation. So this is all referred to as the microcirculation because of the fact that these capillaries are microscopic. It says many body tissues have an extensive capillary network, like our muscles, kidneys, liver tissue, but some are going to have fewer, like we talked about what doesn't have a good blood supply. Things like a lot of cartilage, none, ligaments, tendons, a poor one. Okay. Capillaries are then referred to as exchange vessels. The reason they're called that is that's where the exchange takes place between the blood gases. We exchange O2 for CO2. We exchange nutrients for waste and things like that. Okay, so when you look at a capillary, because it has to make this exchange, the capillaries essentially are very, very small in their makeup, and the capillaries essentially here, if I can bring the picture up, which I seem to have real trouble with doing this for some reason. Okay, here's what a capillary looks like right here. Let me scroll out, get a little bit wider image of this capillary. All right, and when you see the capillary here, if I can bring this out, which apparently I can't, let's move it across this way. All right, and move it across here, and I probably can't squeeze that out of there. Okay, so I'll just label these for you. All right. First of all, when you look at a capillary, you only have two layers in the capillary. All right, so we have what's known as the endothelium, the inner lining right here for the capillary. All right, and then you have outside of that is the basement membrane. Okay, so we have an endothelium and a basement membrane. It's the only two layers in a capillary, and they've got to be thin so that those exchanges can take place between, like I said, the blood gases as well as the nutrients and the waste. Okay, it says in some organs, number 4, there are what are called sinusoids, which are a little wider, more tortuous capillaries, right? And things like in the liver and places like that, we have sinusoids or sinuses, which we'll talk more about a little bit later when we get into those specific tissues. All right, and I will try to bring this back one more time. And apparently I'm going to have issues with this all day as we go through this lecture, but we'll deal with it as we have to. And then back in our outline, essentially states the next thing is a portal system. Delivers blood by way of a portal vein from a capillary network to another capillary network, and we'll talk about that when we do the hepatic portal circulation and look at that in our liver, all right, a little bit later on. So now we go down here and we're at the bottom of our picture. Now we see the venules. So once again at the top here we had the arterioles, right, leading to the meta-arterioles, which went to precapillary sphincters, which went to the capillary network itself. From there, we're going to have a post-capillary venule, right? That's number 1 under venules. So the capillaries are going to merge together, form a post-capillary venule, which then is going to lead into these larger ones known as muscular venules. Okay, and the venules then primary function deliver blood from the capillaries then to the veins. So let's go back to our opening picture if we can, and we'll see our picture of the veins here. And we might be able to do that, we might not without pausing. So hopefully when I make these little pauses it doesn't interrupt our lecture too much. Okay, so now we're at veins. So let's look over here on our right-hand side at the veins. Veins are a little bit different than arteries in that they have much thinner walls, okay? And primarily the reason for that is that the tunica interna is thinner, but more so the tunica media, all right? Especially the smooth muscle layer. Look at the smooth muscle layer here, the thickness of it compared to that of an artery, okay? Now, one other thing that the veins have that arteries do not have, and this would be these structures here, which are known as valves, okay? And we find those especially in the limbs, and essentially those valves then are made up of 2 or more folds of the tunica interna, and they form a flap-like cusp, and they kind of look similar to when we saw our cusps in our tricuspid and bicuspid, as well as our semilunar valves. And these are made up more almost like the semilunar valves in the heart and the aortic valve and the pulmonary valve. And they form a flap-like projection, which is into the lumen here. What that does, it functions just like in the valves in the heart to prevent backflow of blood and aid in moving blood toward the heart. So if you were to look at this picture, which looks a lot like our model in the atlas, okay, we would see that the blood would be flowing this direction, okay? So if I actually took my pen and pencil and drew that, and if we looked at that kind of like we did with the heart, we see that the blood could flow this way in this vessel here as it goes through here. If it tried to come down here, it's going to get stopped right there in the cusp. All right. So if blood's flowing that way in the vein, over here in the artery, the blood has to be flowing the opposite direction. Remember, these are going parallel to each other. One vessel's taking blood away from the heart. That's the arteries. The veins are bringing it back toward the heart. Okay. So got to make sure we note that, all right, and you understand that, and that's the way it looks like in the model in our atlas when we look at the model of the arteries and the veins. A couple other terms. Number 3, a vascular or venous sinus, like the superior sagittal sinus in the head, right, is a vein with a very thin endothelial wall, has no smooth muscle, so it cannot change its diameter, right? Like the coronary sinus, same thing. And we have superficial veins that travel through our hypodermis. Those are the ones you can see in your body when you look at your face or you look in your arm. You can see blood vessels, you see veins in your arms, legs, things like that. Okay, those are superficial veins. And then we have the deep veins that travel deep below the fascia between our skeletal muscles. So we have deep arteries, deep veins, and we do our drawings here in a little bit. When we draw out the veins, we'll do some superficial as well as deep veins. Now, another term here, we have anastomosis. Okay, anastomoses, plural. So when we have two or more branches that are going to supply the same body region, it's called an anastomosis, just like you had on letter H, but put S-I-S. Anastomosis, anastomoses, the next word in plural, provide alternative routes or collateral circulations for blood to reach a tissue. So that if we have a blood clot, a blockage of blood flow, as long as we have an anastomosis, we have another way to get blood to a tissue. Okay. Arteries that do not anastomose, number 2, are called end arteries, E-N-D, because it only has the one blood supply to that tissue, and if that gets occluded or blocked off, so it says occlusion of an end artery interrupts the blood supply to the target tissue, which may result in what is known as necrosis of that tissue, which is a pathological death because it does not have oxygen. Okay? Real quickly, under blood distribution, systemic veins and venules at rest contain about 64% of the volume of our blood, so they are known as blood reservoirs. You don't have to know the 64% for me. When more blood is needed elsewhere in the body, we undergo vasoconstriction, which reduces the volume of blood in some of these reservoirs so that we can get more blood to the tissues that need it, like skeletal muscle tissue, right? Vasoconstriction of veins, called vasoconstriction, or specifically in this case venoconstriction for the veins, also helps to compensate for blood pressure decrease during hemorrhage. So if you get cut and you start to bleed, those blood vessels, especially the veins, will undergo constriction to limit the amount of blood that's leaking out of our body, essentially, right? To try to prolong our life. Major blood reservoirs are the veins of the abdominal organs, primarily. We think of the liver and the spleen, as well as our skin. So now we're going to move into the circulatory routes. I'm going to talk about the different routes, all right, the different areas and regions and circulations we have to different parts of the body. Okay. Okay, so here we just have a generalized picture of some of the major arteries in the body, okay? So the circulatory routes are going to include the following, and we're going to do each one of these as we go through them. Number 1, the systemic circulation. Systemic circulation includes all body vessels carrying blood from the left ventricle through the body organs and back to the right atrium. The subdivisions of this will include the coronary or cardiac circulation, which is the blood flow to the heart, which is what we covered in our muscle models, right? Letter B, cerebral circulation, the circulation to the brain. And letter C, hepatic portal circulation, which we'll cover more in depth in a little bit, all right? So that's the systemic circulation. Number 2 is the pulmonary circulation, which includes all the blood vessels carrying blood from the right ventricle through the lungs and back to the left atrium. So all these we did on our drawings, essentially 1 and 2. Remember we said the left side of the heart was a systemic circuit and the right side of the heart was a pulmonary circuit. Then number 3, we have fetal circulation, which exists only in the fetus and consists of structures that permit exchange of substances between the developing fetus and its mother. Okay? So let's talk about the systemic circulation first, all right? And we're going to cover it in our drawing in just a second. So this is going to, again, remember, leave the left ventricle, the left side of the heart, okay? Systemic circulation is going to take oxygen and nutrients to the body's tissues, removes the CO2 in the waste, all right, as well as heat from the tissues of the body. The systemic arteries branch from the aorta, which consists of the following segments. We have the ascending aorta as it leaves the heart and goes upward. All right, then we're going to have the arch of the aorta as it bends to the left. And then it's going to continue as the descending aorta, which has 2 parts above the diaphragm. We're going to call it, letter C, the thoracic aorta. And then below that, we will have the abdominal aorta. Okay, and then number 3 for the veins, I don't have a picture of it right up here with me, as the veins bring blood back toward the heart. Okay, and empty into the right atrium, we'll have the superior vena cava, the inferior vena cava, and the coronary sinus. All right, so we're going to stop right there with that in our notes, and we're going to pause on the notes while we actually sketch out and complete the drawings we have. So the drawings in your outline, the one I told you to download hopefully for the arteries, as well as the fetal circulation, and you have a drawing in your packet there for the veins. So we're going to pull those out and we're going to draw through those. I actually have these pre-recorded. So So essentially what we're going to do here now is this is going to be the end of what I'm going to call part 1 for the blood vessel lecture. And then I'm going to have separate individual recordings for the drawings for the arteries, and another drawing for the veins, another drawing for the fetal circulation. Okay, and then I will have another recording, a 5th recording to make up this whole lecture, and that 5th recording will be essentially blood vessels part B, I'm going to call that. Okay, part B, is we'll finish that up. So the way I would like you to watch this is watch this obviously first, then watch the drawing of the arteries, and do that as you draw and complete your artery handout. Do the same with the veins as we do that handout there. Do the same then with the fetal circulation as well as circulation to the brain. So you really have 4 different videos to watch and do those drawings, each one of those as part of this lecture. And then when I go to the blood vessels part B, that'll be a final lecture just like this as we finish filling in the notes for this chapter. Okay, so that's going to be it for part A. We'll stop there, and then I will upload this as well as the other parts into YouTube and put those into Canvas. Okay, all right, so that's it for part A, and go into your modules and you will see the other ones to open up as you go through the drawings here. All right.